So in this video we'll be doing we'll be trying to represent functions so power series in terms of functions. So exactly we're given a function like this one. Okay, we have 1 all over 1 plus x, that is all squared. So we're supposed to use differentiation to find the power series. So we're using diff to find the power, trying to find the power series, right? Cool. So okay, let me just hold this aside, put this here. We know how to find a power series of something like, yes, a power series representation of the function of a function like 1. Let me just use minus so that it will be easy. This is the same thing as this one, right? We know how to find this one. It's going to be n is equals to 0, and then we'll have x and then power n. Okay, this is so easy, but we want with 2 here. Okay, so that's how can we do that? Okay, we know that if we can differentiate here, we can. Okay, let me just rewrite to this one to a point that you can actually see it. I'll rewrite this here. First, let me just rewrite this as 1 plus x. Okay, after rewriting as 1 plus x, I can rewrite this as 1 plus x to power negative 1. So I notice if I take if I differentiate this in terms of x, dx of that, I can have take this, so it would be negative 1 and then minus 1. That means I'll have a 2, then I'll have 1 plus x, then a negative 2 here. So now it's going to be negative 1 all over 1 plus x all per 2, and this is very close to what we are interested in, very close. So we can just differentiate this and get something very close to that. Okay, that's nice. So that means I'll differentiate this side, I'll differentiate both sides, dx of this whole thing, dx of the whole thing. I already did what is going to happen here. I think I'll have minus 1 all over 1 plus x squared. Cool. So what is going to happen on this side if I differentiate in terms of x? Before I do it, let me just rewrite it or simplify it so that I can see what is happening. N is equals to 0, and then here it's going to be n1 and n and x. I want to show this power, this alternating thing, to be just outstanding for you to see that we are working with an alternating series. Okay, I'm still taking a derivative, right? dx. I haven't. So I'm only differentiating in terms of x. Everything without x is just not affected. We're only going to change things with x. So then it's going to equal to, if I differentiate in terms of x, sum, then I think I'll have here, if you're differentiating, you're losing the first term, the 0 term. Okay, so that means now it's going to start at 1. Okay, then this will be a constant, it won't change because it have nothing to do with x. This one has an x involved. This x will go in the bottom, and then we'll do x minus 1, and then we are good. I can take this negative to the other side by multiplying by it on both sides, same as dividing. 1 plus x squared is equal to what is going to happen here. Okay, so if I multiply by this minus n this side, there is also something with the base n, so laws of exponent, you can add them. So I'll have sum n is equals to 1 here. That will be minus 1, but now this is minus 1, so it will be n plus 1, and here I'll have that n waiting for me and x minus 1. So I think here you could just end your thing here, but I think I need to make this one have 0 again. So you know that, let me just put it like this so it'll be easy. If you add here, you subtract here. If you subtract here, you add here. So it's going to be 1 all over 1 plus x squared. I want to make this thing have like x only n, so I'll have to add 1 here. If I add 1 here, I'll subtract 1 here. So that will be sum, and then to infinity from n is equals to 0 because I subtracted. I think this was plus 1 here. If I said if I add here, then I said I add everywhere, right? So it's going to be minus 1 n plus 2. Then if I'm adding that, I have to add everything with n, so there's going to be n plus 1, and then that is going to be x n all alone. So I think this is still alternating with without that 2, it's just shifting it. So I don't think the 2 is so important. We could just take it off. It doesn't add value or change anything in how the series behave. So I think now we've solved our thing, because we wanted to represent this like this. Also, the follow-up question could be like, find the radius of conversion. So radius of conversion, you're always going to get it from this thing here. So it's going to be that's negative x absolute less than 1. So obviously our r is going to be 1. So that's easy, right?